So when I was a student in high school, our English teacher assigned us a nonfiction literature circle project. The work that our group mistakenly chose was The Hidden Reality by Brian Greene. It was a mistake because of the complexity of the subject. And to be quite frank, the fact that there was no Spark Notes or Cliff Notes on this book published by January 2011. But in actuality, the subject of the book was quite interesting after we read it. Greene, the narrator, and the author describes the history and current developments of modern theories of multiverses, black holes, and relativity. And he directed the hidden reality toward the common person, which is why he writes in a language that simplistically and relatable, so that anyone, regardless of their educational background, can comprehend his argument. Now, I'd like to explain Brian Greene's explanation in his book, firstly in chapter 2. Brian Greene begins by presenting the simplest theory about parallel universes. Greene claims that if the universe is immersively big, as scientists and physicists say so, then there is bound to be humans that look just like you and me somewhere out there. And these replicas enjoy alternate versions of actuality. Somewhere out there, in this seamless universe, someone that looks just like you is watching a TEDx talk about the theories of multiple realities and multiverses. In this infinite universe, there aren't just one or two doppelgangers, there are infinitely many. In some, there might be a duplicate of you listening to this very sentence. In others, there might be listening to this presentation 5 minutes ahead of us, or behind us. The possibilities are endless. With the simplification of the theory itself, Greene establishes ethos as he can describe the theory without having to obscure jargon and can give analogies that the common human being can understand. In this chapter, Greene travels deeper into the world of cosmology by explaining the inflation theory. The theory states that the universe inflated at a ridiculous exponential rate almost immediately after the Big Bang. With the burst of spatial expansion, parallel universes were generated. As the expansion is still progressing as I speak, many more parallel universes are being generated. The expansion of the universe continues, but it was slowing down due to gravity. Greene suggests that the equation for spatial expansion is dependent on the inertia of the objects in the universe. By explaining such a complicated theory, Greene establishes his credibility on the subject of inflation, as well as convinces the reader that the inflation theory is very much realistic, as the theory itself sounds like a bunch of mumbo-jumbo, if not dumbed down for the average reader. This chapter talks about the famous string theory. String theory states that everything is made of one-dimensional point, like the particle called strings. The strings propagate through the space and time and work with each other to create matter. String theory first arose when the attraction forces between atoms were first questioned. How could nuclei attract electrons but repel them at the same time? Another theory about the multiverses, one about cyclic multiverses, this theory derives from Einstein's hypothesis of the origin and destruction of the universe itself. Physicists today are able to discover that the universe is expanding through observing a phenomenon called the red shift. Now this is an interesting concept, and here's why. According to the common sense, the gravity should be pulling everything in. However, instead of everything in the universe is expanding. Einstein theorized that this result was that of an oscillating universe. According to this theory, the universe is a self-sustaining cycle, one that begins with a big bang and the one that ends with a big crunch. Based on this theory, there are likely to be multiple universes cycling at a time. This is rather another effective argument presented by Greene. In this chapter, Greene is combining the use of citing reliable scientists such as Steven Weinberg and Einstein himself in order to establish support for his arguments from reliable sources, or what your high school English teachers taught you as ethos. Also, by efficiently explaining the theories, Greene simultaneously establishes the logos. Once more, Greene focuses upon physics theories and laws that have been proven as well as that can be observed in the physical world, such as gravitational force, acceleration, etc. Certain theories or laws based on atoms, electromagnetic waves, theory of relativity, and even quantum theory cannot be seen by our sensory inputs, but by their impact can be observed, which can be taken to be a governing rule. Many times the theory's architecture can help learn the results. much like how the black hole emerged from mathematics of general relativity, and astronomical evidence which verified it. Coiled, inflationary, brane, cyclic, and landscape multiverses are different multiverses based upon the string theory, as stated by Green. With the use of logos, Green tries to argue how multiverses are based upon string theory, which is beyond our present knowledge. Although such theories exist, we do not have the means to verify their credibility, even though it may support by their calculated statistical data. This chapter focuses on the correlation of quantum mechanics to a theory of multiverse. This is a very interesting concept, as pointed out by Green. First, understand how quantum mechanics allows the argument to be made for the multiverse. It is vital to first understand how quantum mechanics work. Quantum mechanics in a nutshell, is a science that explores physics behind subatomic particles. Unlike larger objects, subatomic particles do not have the Newtonian laws of physics as larger objects do. Larger objects actually don't either, but we'll get to that in a moment. This means that instead of following a precise projection, subatomic particles have a range of locations they could be at once. According to Bohr's quantum model, when we observe a subatomic particle, the possibility waves shrinks to a random location on the wave. The process actually happens in a larger everyday objects too. However, the possibility of waves are so narrow and uneven that is so rare, as in maybe once and out of a couple billion years, that this large object will appear at a place unpredicted by Newtonian physics. However, the shrinking of a possibility of a wave is one theory, and is precisely only a theory because it conflicts with the concepts mentioned in Schrödinger's theory. According to Schrödinger's equation, which has been proven in actuality, the possibility does not shrink upon observation, but instead the particle simply is observed in two places at once. Everett, however, thinks this is, as he put it, sloppy thinking. Everett believes that instead of having multiple observations simultaneously, for every time the possibility wave is supposed to spike, parallel universes are created. Each parallel universe contains one of the many possibilities. If this is true, there are Google upon Googles of universes that exist. This is just another many of the theories that prove that a multiverse is not only possible, but plausible and very likely. Yet another theory about multiverses is that the holographic universe. Think for a moment, what if the universe is just a hologram? Although this idea may seem absurd at first, it makes more sense when you take a more in-depth glance at black holes. There's a law in quantum mechanics that states that information cannot be lost, that it can only increase in entropy. At first, this law seems to be violated in black holes when a black hole is destroyed. However, upon further investigation, it was found that after all the information is not destroyed, but left residue. This residue contains the highest possible density of information in the universe. This information can be projected as a hologram. This is an interesting theory because this means that as we know it, if the universe could be just a hologram that we live in. Maybe this theory seems a little bit wild, but if this were the case, there could be multiple holograms and therefore multiple universes. By providing us with the sheer amount of information in this chapter, as well as what the one before the chapter, Green makes it seem very possible and almost certain that there could be possible multiple universes. This is precisely why I find Green to be so impressive. He took a topic that has actually many controversies over it to a conclusion that seems inevitable. Green begins the chapter by revisiting the topic of parallel universes and the established fact of quantum mechanics as discussed in the previous chapters. You may think creating a galaxy is ludicrous, but on the other hand, Green doesn't seem to believe so. In a distant generations, human race will most likely be in the possession of technology required to create new universes, whether it be usual one or the less tangible one. The less tangible option one refers to universes created virtually on computers, which may occur sooner than we imagine. Moreover, this may lead to some interesting inquiries, quite possibly to question whether math is real or just an illusion created by our brains to cope with the complex reality around us. But we still remain with a question. So how do you suppose we create the vast space and energy we know as the universe? Well, scientists have studied the inflating theory, which is responsible for the cosmic inflation in the early universe as particles rapidly expand for the brief period of time, thus creating the universe. However, this is just an idea, and the inflating field must be harnessed for the opportunity to create such universes. Furthermore, Green informs us one of his dreams, which he actually led to learn something rather abstract but salient. As with the use of ethos, Green establishes that he understands the world around us, much like a rock which doesn't change much. On the contrary, our perception is inconstant. To conclude his book, Green explains throughout his last chapter about how much the human mind is capable of as he resurfaces the idea of parallel universes and mathematics once again. Though in particular, he questions the beliefs in mathematics whether it is being taken too seriously or not seriously enough. Incorporation of logos was essential to understand the usage of examples or different scientists from the past should show the vast development in physics. Specific scientists within the book who made advancements in major theories, such as the quantum theory, in all seriousness, used math to possibly have discovered the notable evolution in the scientific exploration. As we have mentioned earlier, Green riddles his book with direct arguments in each chapter. However, throughout the entire book, his general purpose is to foster interest and education of sciences, more specifically physics, in children. Now, after reading this work, I continue to ponder Green's words. I believe that mathematics is the central guide to discovering and expanding modern theoretical physics. As we have seen in the past, physicists have based their findings on mathematics. Intuition is not the principal key to actualizing physics, which is so abstract and intangible at times. Although intuition may lead us to some ideas. Like if the scientists were to ponder, if mass causes gravity, what if there is something that is infinitely dense in mass? This curiosity or intuition may lead to new research, but it is mathematics that qualifies it. Say for example, notion and equation coincide and match. The idea is correct, end of the story. However, if notion and equation are dichotomous, then there is an impasse. But in the end, is it someone's curiosity that we trust or the mathematics disproving it? So to answer this question, instead of inciting a ferocious debate, impassioned by our love of science, let's examine past cases. Albert Einstein, who conjured the majestic theory of general relativity, poses a great example. When his theories were posed by Hugh Everett's mathematics, then Einstein had to reconsider them. This case was mentioned in Green's novel and serves as an awesome example of numbers. More so letters nowadays. Trumping human perception of phenomena. And I love this case especially because the greatest mind at the time was opposed by initially a no-name graduate student at Princeton who had his master's thesis rejected for not following the ideas of scientific community. Many other examples, such as Schrodinger's equation, Feynman and his double-slit experiment, and Maxwell's equations that pioneered electromagnetism, all show how mathematics is the principal foundation for physics. I mean, how can intuition be truly trusted if we're studying an intangible, unknown, and invisible phenomena of the universe? That means that people's curiosities are just ideas thrown out at the unknown with no real concrete proof, but mathematics supplies empirical data. Thus, mathematics serves as the limits of inquiry. Thank you.